Hello guys, in this video I would like to explain about Durbin-Watson test, which is usually called DW test, and I will just explain the background of this test, and then I will explain that for what purpose you can use this test, and then I will explain this in Python, that how you can conduct this test in Python for your analysis. That in a regression analysis there are various assumptions, and I have talked about this earlier when I was talking about simple linear regression. This is a series of lecture about regression. So we have done a basic regression. What is the simple linear regression? Then in case when the data is not normally distributed, what we can do. So we have done lecture on transformation. Most precisely we can say on Box-Cox transformation. And there is another assumption. So that is about normality, that the data is normally distributed. And there is another assumption that the data should be independently distributed. So when you perform your regression analysis, you need to check the residuals of the regression, whether it is independently distributed or not. So maybe there are other tests which you can use, but we will use Durbin-Watson test, which is a very popular test, and you can use this test to test the autocorrelation or serial correlation in the data. It is not necessary that you are using this only for to see the assumption of regression. The residual of the regression you can use for other data. I mean, you want to check other data, normal data, the other data to see whether it is correlated or not. So this test is usually used to see whether is there any autocorrelation in the data or not. There are other tools like the autocorrelation function, partial autocorrelation function, but this test will give you numerical results, so you will be satisfied whether there is autocorrelation in the data or not. So we will test the assumption of the regression, that is state that the error terms or the data is independently distributed, each observation. So let's just go to some basic theory, and then I will come to Python, that how we can explain this. Okay, so you can see this is the assumption that statistical independence of the error, the particular no correlation between consecutive error in the case of time series data. So the regression data, of course, but that is also time data recorded with the time. So independence in the error. So that's important. You need to keep in mind this point. And then you can Google and you can see a lot of things about Durbin-Watson test. This is some video about, so you can see the detail about that how you can test. Here you can see in the figure as well, in this one. If you see that, okay, initially we need to see about the null and the alternative hypothesis. You can see that the null hypothesis, no positive autocorrelation, and then there is another null hypothesis with the steric, no negative autocorrelation. So I mean that score both no negative and no positive autocorrelation, because there is different conclusions about negative autocorrelation and positive autocorrelation. So this means that if the value of D, which is say the Durbin-Watson test, let us take D test. If the value is 2, or just you can say around 2 or something like this in this region, then you can do not reject H naught or H naught steric, or as mean both. So this means that we accept these hypotheses and say that there is no autocorrelation, whether it is negative or positive in our data. But if it is on this side, it is less than 2, then we can say reject H naught, evidence of positive autocorrelation. So we can say there is positive autocorrelation. Okay, zoom up in this region. So if it is near to 0, this means that there are high positive autocorrelation. And similarly, if it is near to 4, then you can say there is negative, strong negative autocorrelation. And in this region, it's okay. And particularly in this region, you can say, okay, there is no autocorrelation. If you want to see detail, you can Google and you can see further theoretical detail about this test. But you should keep in mind that this test is used to test whether the data has autocorrelation or not. So this is some theory about the test. And now let's move to Python, that how we can do this test. You need some libraries, which usually we need NumPy and pandas. You need to, I already did, but you need to load this, import this, and some function, specific function like linear regression. And the other as well, Durbin-Watson. This is important, otherwise your test will not work. And this is important to plot what you need to plot. Okay, this is for reproducibility, and I need to do this, and then just create a data. We already discussed about this, that how we can create different data set. So this is just the generation of independent variable x and dependent variable y. And of course, you should have your own data, that there will be x and there will be y data. Y is response and x is covariates or predictor. Or you can use online data, you can generate your own data, whatever. I have done a video on random number generation in Python, so you can go sorry, you can go and see that video and you will see how these number can be generated in Python. Now just make a data frame, and then you have x for covariate and y for the response variable. Just click. Okay, first generate this data, and then this function give you a data frame with the x as a covariate variable and y variable as a response variable. You can just check here data, just write data and then click, and you will see, just go. This is now x covariate and y is the response variable, and you can see the first 4 values and the last 5 values are 6 values. This should be as independent 5 values. So these can show the value as well. Yeah, 5 values in the beginning and 5 values in the end. Start from 0, so end with 99. Okay, so now you have data, and this you should have already. I'm just generating because I don't have now ready data. This is now another function which is very important. This statement is important. Now I'm splitting the data into test and train data, and by setting rand this equal to 42, the split will always be the same every time the code is run, ensuring reproducibility. So the purpose is only this, that the data will be split in the same way. So this is just for this purpose, to reproduce the results. Remember, this is the important. The other thing are clear, but this was unclear, so I just wanted. Now you x train x test, this function train underscore test underscore split, and then the data x. This is the covariate and the response variable, and test size is 2. So this is 20% will be going to test and 40% to train, and this will store x train data, and this will store x test data, and they will store y train data, and this will store y test data from this function. So this function will store corresponding data in each of these terms: x train x test, y train y test. So run this. When you run this, you have data now: x train x test, y train y test. Now just run the regression. Just define the model is a linear regression. Now the model is a linear regression, and now model dot fit, this will fit this linear regression with the x train covariate and y train as a response variable. Okay, now just do prediction for the training period because we need the residual. So then we need to calculate the residual and test whether the data has autocorrelation or not. So now we have prediction. For residual, we need prediction because residual is the difference between the actual values and the prediction. So now this is the residual. Residual train is equal to y train original data and then the predicted data. Okay, now we have this residuals. Okay, I don't need to use this function because this is actually for using the test residual as well. You can use both, you can combine by using this function, but I'm just using the train now, the train residuals. So I'm just assigning this residual is equal to train residuals. Nothing to do. If you want to use the train residual in these functions below, then you don't need to change this. I'm changing this. And now this function will calculate Durbin-Watson statistic and store the result in DW statistic. Now calculate and you show the result. So the result is 2.238. So this is just, very close to 2. So we can say, okay, the residual has no autocorrelation, and maybe if there is very less, so you can ignore this in this case. And yeah, you already know that how to know. This is the criteria, or you can say in detail in the video, and you can decide about like this. You can decide whether we reject or not reject. So yes, in this case, we accept the null hypothesis and there we say that there is no autocorrelation, no positive, no negative autocorrelation. Okay, now if you want to plot the residuals with the covariates to see how it look like, you can just use this, the figure size and then the train residuals. Okay, yes, and then test. I just commented the test, so I don't need to plot the test residuals. And then you need to plot a line. So this line is y0 because we need to see whether the residual has a mean 0 or not, just to draw this line. And then you need to label this figure with these. So you can see that this is approximately, yeah, this is just, approximately some are above, some are below. So this can be close to 0. Yeah, there is some outlier like here. But yeah, it look like this. And if you want to see the summary of the residuals, so you can use this function residual.describe, and you will see how the residual look like, how the summary statistics. You can see the mean value because this is the assumption that the error of the regression model will be distributed normally with zero mean and a specific variance. So we are not talking about the variance now because this has some specific value, but we know the value. We don't know about the value of the variance, but we know the value of the mean, that is 0. So you can see minus 1.110 e raised to the power minus 15. So this is of course very near to 0. So the residual is distributed with 0 mean and some specific variance. And also we know that there is no autocorrelation. So I think this is enough for today. And the next video perhaps we will do some prediction with the regression model and see the performance, and then we can see if the data has autocorrelation, then what is the solution, because in the reality it is not necessary that the data will have no autocorrelation. So this was one of the data which don't have the autocorrelation. So I think this what we have learned in this video, we have learned about what is Durbin-Watson test, why we need this test in particular in the regression analysis, and how we can use and decide about the null hypothesis, and then finally how we can implement this in Python and see and reach to a particular conclusion whether the particular data has autocorrelation or no autocorrelation. So thank you very much and see you in the next video. Ciao.